About 60 years ago, a scientist in the Soviet Union, Boris P. Belousov, was trying to model the Krebs cycle. Purely by accident, he observed that a solution of citric acid, acetified bromate, and a steric salt oscillates periodically between yellow and clear. He submitted the findings of his oscillatory reaction for the publication, but it wasn't published because nobody could believe it. Fortunately, the experiment was again taken up some year later by another Russian biophysicist, Anatol M. Zhabotinsky. Zhabotinsky refined the reaction. He replaced citric acid with malonic acid and discovered that when a thin layer of the solution is left undisturbed, fascinating geometric patterns are observed throughout the medium. Thus, the reaction has a pattern in both space and time. Zhabotinsky was ultimately able to overcome the sense of disbelief. Today, the reaction is popularly known as the Belousov-Zhabotinsky reaction. Let's take a look at the reaction. We need three solutions: a solution of potassium bromide and malonic acid, an aqueous solution of potassium bromate, and a solution of acetified cerium ammonium nitrite. Stir the mixture using a magnetic stirrer. The solution changes between yellow to clear due to change in the concentration of cerium ion with 4 charges. To visualize the reaction better, add FERROIN solution drop by drop till the mixture becomes red. The red solution suddenly turns blue and then back to red. This goes on and on as if it is a chemical clock. Now let's put a thin layer of the solution in a petri dish and leave it undisturbed for a few minutes. We see the evolution of blue dots that become rings of red and blue. Soon, the whole petri dish is covered with patterns. The reaction has two main parts. First, the autocatalytic oxidation of cerium by potassium bromate, followed by the reduction of cerium by malonic acid and its bromoderivatives, which are produced during the overall reaction.
A crucial aspect in biological study is to study the origin and development of form and function. But interestingly, the dynamical nature of such form and function has led people to see Belousov-Zhabotinsky like pattern-forming systems in development in cells at molecular scales. And in fact, more interestingly, recent results have shown experimental evidence for bacterial center-finding proteins that in fact form those beautiful spiral patterns that you see in an organic BZ reaction. So in fact, wherever you look in biology today, you find aspects of this BZ reaction turning up, and this is only now beginning to get explored in greater detail.
The experiment, which Belousov wasn't able to publish, has proved to be very inspiring for both chemists and biologists. Today, more than 1,000 of papers have already been published based on the principal idea of BZ reaction. That's a happy ending for a sad story.